Welcome to Pure 2, Chapter 3, where we are going through a series of lessons, sequences, and series. In this lesson, this not in this lesson, but in this series of lessons, you're going to learn about different kind of sequence and series. The main ones are arithmetic and geometric. You're going to also learn about sum to infinity and beyond, just like Buzz Lightyear, and also some different new notation. If you've done further maths, you might have seen it, but if you haven't, you will find this new. It's called sigma notation. Then we look at recurrence relations and modeling. Right, so this lesson is all about the arithmetic sequences. Let's have a look. Okay, so we've got different type of sequences which you have learned in previous years. This one, if you notice, we're adding three each time. Okay, this is called a arithmetic arithmetic sequence. The second one, where you are going to multiply by 2 each time, this is called geometric sequence. So if you add the same number or subtract the same number, that's called arithmetic. But if you're multiplying by the same number, that's called geometric. The last one is a very special sequence. See if you're able to record the name of it. Yep, it's called Fibonacci sequence. So what's so special about Fibonacci sequence? You do 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5. Actually, this is what we call the recurrence relation, which we'll look at later. So this is a type of recurrence relation. So terminologies. So n, okay? So n stands for the position of term. The position of term. So un is the nth term. Now, so say, for example, we've got 2, 5, 8, 11, and 14. Okay, so what we know is, okay, for example, let's say the 8. Okay, so 8 is a third term. So in here, 8 is the third term. So in this case, we can say U3 is 8 because the third term is 8. So U3 equals 8. Or you can say, let's say, or U14, U5 equals 14. Right. What else do we know? Well, we can also know in this sequence, this is the nth term. So the nth term is, if you do your GCSE stuff, you will know nth term equals to 3n minus 1. Yeah. So that means un equals to 3n minus 1. So that's what we mean. Okay. So un is the nth term. Okay. So there's some terminology set that you have to know. Next one, arithmetic sequence. So an arithmetic sequence is one. I'm going to type it out because my handwriting is very pretty, as everyone knows, which has a common difference between each term. So it's a common difference between each term. So common difference means plus or minus. So the nth term of an arithmetic sequence, now you must remember this, okay, is un equals a plus n minus 1 times d. So un, this is the nth term. So nth term equals to, so a, okay, so a is the first term. D is the difference. So we can have a look how we can use this. Okay. Example. Okay. So before we look into the using the formula, let's get used to using U1 and U2, etc. So the nth term of an arithmetic sequence is UN equals 55 minus 2n. So this is the nth term. So this is the nth term. Okay. Rather than the first three terms of a sequence. So let's get used to using the U terminology, the symbol, the notation. So U1, the first term, okay, equals to 55 minus 2 times 1. You can see if you highlight the 1 in here, that would same as the 1 in here because we're replacing n on both sides of the equation. So u1 equals 55 minus 2, which is 53. u2, which is 55 minus 2 times 2, which is 51. u3, which is 55 minus 2 times 3, and that would be 49. So that's u1, u2, u3. That's the first three terms of sequence. Okay, part B. Find the first term of sequence that is negative. So to find the first term that is negative, so what you want to do is you want to let un, so you want to let un equal 0. So we can see the sequence is decreasing from 53, 51, 49. So if we let un equal 0, we're finding out which term does un give us 0. So 55 minus 2n equals 0. So 55 equals 2n. If you divide by 2, n equals 27.5. That means by the 27.5th term, n will be 0. Therefore, n is 28. That means by the 28th term, it will definitely be negative. You might be asking, why is it not 27? Because the sequence is decreasing. That means 27, because that means if 27.5 reaches 0, that means 27th will still be positive. So 28th will be negative. Okay, because the sequence is decreasing. So each term is getting smaller and smaller. Right, example, let's try to use the formula. Okay, so let me write a formula again. Un equals a plus n minus 1 times d. So, example, find the nth term of each arithmetic sequence. So you can obviously use your GCSE method. It still works. Basically, that is the same as this method in here, this formula in here. So the GCSE method still works. But if you don't, if you wouldn't use the more proper way, a formula, oh, let's learn how to use this. Actually, you'll learn how to prove this formula later. So might as well learn how to use it. So we know a is 6. First term is 6. The difference is we're adding 40 each time. So therefore, un equals to 6 plus n minus 1 times 14. If we expand the bracket, multiply 14 to bracket, 6 plus 14n minus 14, then you have 14 minus 14n minus 8. That's the un. Okay, how do we verify the answer? If we put 1 in there, 14 times 1 minus 8 is 6. That gives you the first term. Sub in n equals 2, 14 times 2, 28, minus 8 is 20. That's the second term. That's how we can verify it. Question B, okay, do the same thing. A is 101. The difference is we are subtracting 7, if my mental maths does not fail me. Yep. Subtracting 7, so the difference is negative 7. So un equals to a 101 plus n minus 1 times negative 7. Expanded bracket, so 101 minus 7n plus 7. So un equals to 108 minus 7n. Okay, that's the answer. Right. So have a go. Okay, your turn. Question 1 and question 2. Question 1, write down the first 4 terms of a sequence and write down the a value of a and d. So you can refer to the first example and this one. Find the nth term. Find the nth term. It's typo. And the 10th term of sequence once you found the nth term. Okay, pause the video. Have a go at the question. When you're ready for the answer, you can press play. Well, here are the final answers. Okay, quite straightforward. I would think quite simple. That's why I'm not going to explain too much. So you can have a look. I did try to write as much as I can. You don't have to write the calculation in the middle. You can just put the calculator. I'm just showing what I would do when putting in calculator, just to make sure everyone's happy with the explanation. So let's move on. Right, example. A sequence is generated by the formula. So un equals am plus b. Now from this line, you can tell, okay, this is a linear sequence or this is a arithmetic sequence. From the nth term, you can tell because am plus b is a linear, okay? So where a and b are constants to be found, given that u3 equals 5 and ua equals 20. Now I do want to explain the two ways you can go with this question. If you want to pause the video, you can have a go with a question really as a practice. Before we start, let me just say, okay, this is the third term. Okay, so u3 equals 5 means this is the third term. Third term is 5. The eighth term is 20. Okay, right, so there are two ways you can do it. The first way, method 1. Okay, so method 1. We can use the formula. Okay, or use so we know un equals an plus b. So if you sub in 3, so u3 equals to 3a plus b, and we know this is 5. And u8 is 3, not 3. N is 8, so 8a plus b, which is 20. Then from here, you can do simultaneous equation. Obviously, you can use a calculator to help you solve a linear simultaneous equation. I'm not going to show you how to do this because you can easily work it out using a calculator. By the way, you don't get any marks for showing how you solve this simultaneous equation, linear ones. Linear simultaneous equation, you don't get any marks for showing how to solve it. So in here, I'm just going to give you a equals 3 and b equals to minus 4. Method number 2. Okay, now this actually method proven to be quite useful later on for geometric as well. So which is essentially count the terms. So we're going to count. So we count the terms. So U3 is 5. That means the third term is 5. Okay, and in the eighth term, 4, 5, 6, 7, 8, 20. So 3, 4, 5, 6, 7, 8. Yep. Okay, so this third term, this eighth term. So because we know it's an arithmetic sequence, that means we're adding the same number each time. Right? So we're adding the same number each time. So 5 plus 1, 2, 3, 4, 5. 5 jumps. 5 times n equals 20. Let's not use n. Let's use x. So we know that's x. 1, 2, 3, 4, 5. Yep, 5 jumps equals 20. Okay. Or you can say, 5 jumps is 15. So then 5x equals 15, x equals 3. So therefore, if we know x equals 3, so then what we know is an plus b. Then if we know the jump is 3, then essentially what we know is work backwards. This will be 2. This will be 2 minus. Would it be 2 minus 3? Yeah, 2 minus 3 would be minus 1, right? And if you remember the GCSE method in here, what we know is actually, so this is the first term, right? This is the first term, second term, third term. To work out the nth term, we can work out the previous term. Okay, so we can find the previous term, zeroth term, which is minus 4. So if you remember the GCSE way, which essentially the nth term is the difference 3n, and then find the zeroth term, minus 4. Okay, I know probably this way, probably easier for this question, but when we encounter a similar example where we have to count the terms, I'll show you. So next example. Find for which values of x would the expressions minus 8x squared and 17x form the first 3 terms of an arithmetic sequence. Now, first of all, again, you can pause the video, think about this, okay? First of all, I want you to recall what is arithmetic sequence. That means a sequence that has the same difference, I will use the word arithmetic difference, okay? Arithmetic difference. Difference between each term. Essentially, if minus 8x squared, 17x are the first 3 terms, then essentially what it means is the difference between minus 8 and x will be the same as the difference between x squared and 17x. Let's call this the difference. Okay, so a difference, therefore, x squared minus 8 should equal to 17x minus x squared. Okay, so the difference, so x squared subtract minus 8 will equal to 17x minus x squared. What I'm trying to do is, for example, if I give you this 1, 4, 7, 10, what I'm trying to do is I'm trying to work out, actually ignore 10. I'm trying to show you 4 take away should equal to 7 take away 4. Okay, so let's do this. But because of minus, be careful, it makes a plus, 17x minus x squared. You can see it becomes a quadratic, so 2x squared minus 17x plus 8 equals 0. Bring all the terms on one side, and then you can put in a calculator. X equals to 2, x equals to a half, or 8. So, yeah, so that will be the answer. Okay, x equals a half or 8. I was just putting a calculator, check my answer. Right, okay, last but not least, exam practice. Okay, you may want to pause the video, have a read through the question, see if you're able to do that. Okay, but if you found it a bit too wordy, want me to go for it, feel free to play the video. So let you have a go. Pause the video, have a go. When you're ready for the answer or explanation, press play. So that's the final answer for part B. Okay, obviously part A, you will need to show how to do that. So I'll go for it. Okay, so sin. Okay, let's call it x. X has been given a 14-day training schedule by a coach. Okay, it will run for 8 minutes on day one, where A is a constant. She'll then increase the running by D plus 1 minutes each day. Now, it didn't say about anything about arithmetic, but you have to realize by increasing D plus 1, it means a constant difference. It means it tells you this is a arithmetic sequence. Okay, so you have to know this. All right. Anyway, so what it means is we start with A. Okay, the next day will be A plus D plus 1 because we're adding a D plus 1. The following day will be A plus 2 lots of D plus 1. I mean, third day because we're adding D plus 1 each time. So then next will be A plus, I'll just do one more, A plus 3 D plus 1. So the difference is we're adding D plus 1 each day, right? Plus D plus 1, plus D plus 1. So if we want to work out on day 14, that means we want to work out U14. So U14 equals A plus N minus 1 times D. We know N is 14, so let me replace N with 14. So let me rewrite this. So U14 equals A plus 13D. Okay, U13D. Now, so A is the capital A, so U14 equals A plus, and D is the D plus 1. 13 times D plus 1. So from here, A is capital A. The difference is just D plus 1 because of a sequence. So U14 therefore equals to expanded bracket A plus 13D plus 13. And that's the answer. Question B, okay, Y has also been given a 14-day training schedule by a coach. Y will run for A minus 13 minutes on day one. So part B. Okay, part B. So for Y, okay, we start with A minus 13 on day one. She'll then increase the running by 2D minus 1. That means the next day will be A minus 13 plus 2D minus 1. And then the following day will be A minus 13 plus 2 lots of 2D minus 1. So you can see each time we're adding 2D minus 1 plus 2D minus 1. So same thing. Okay, let's do U14. Okay, so U14 for Y would be, let me rewrite, A plus 13, not 13, 14 minus 1 times D. So A is A minus 13. 14 minus 1 is 13 times D, 2D minus 1. So expand the bracket, A minus 13 plus 26D minus 13. So A plus 26D minus 26. Okay, right. So because the times, okay, they run for the same length of time on day 14. So we can do this and this equal to each other. So A plus 13D plus 13 will equal to A plus 26D minus 26. The A cancel out. So bring the 13D to the right hand side, becomes 26D minus 13D is 13D. Minus 26 to the left hand side is plus 39. So D equals 3. Okay, and that's the end of the first lesson of the sequences series in chapter 3.